Hello and welcome back to the EduKits holiday coding experience. This is the fourth and last kind of live stream session, the fourth episode in our series, and it's been exciting having you all along with us for the journey. Today we will be building two exciting new Annoyatron inventions. These will be a little bit different from their versions on our website, so it will be exciting to both build them slightly differently and code them slightly differently. We'll be using Cricut again. I hope you guys enjoyed that last time because it is a lot of fun. And those two inventions will be a burglar alarm and the electronic Cricut. And that last one was the invention that started the amazing Annoyatron, actually. That was the very first one I came up with. So let's go through some of the parts you will need today. We'll switch to the iPad cam to take a look at what you need to prepare before we get started. You will need today the Breadboard, which is what we've had what we've been using in all of our previous inventions. Pop that over there. You will also need the buzzer, which we've been using as well. You will need a light sensor, which is this one, and it has two legs that are the same length. Oh, I dropped that. Okay, so went through onto the floor. I will also need you to get a resistor, which looks like this. It's already been bent, and you should have one from one of our previous inventions we built in this workshop. Over to the components you won't have used before in the workshops, but you might have come across these in your own time working through the Annoyatron inventions. We have the ultrasonic sensor. This measures distance, and it kind of looks like a set of two eyes. The way it works is it bounces sound off an object, and because we know the speed of sound, we can figure out the time it takes to get back and use that to figure out its distance. We also have this here, which is a breadboard, and we use this to connect different wires and components together. And I'll show you how we use this later on. We will also need a number of colored wires. Now I have quite a few here. There is 6 wires. Now, what's different about these wires from other weeks is that they are pointy on both ends. So make sure that you don't have a pointy end and a hole end. You need to have pointy on both ends for these wires. And there's 6 of them. Like always, it doesn't matter what color these are because all of the wires work the same. And lastly, you will need the blue USB cable that you use to connect the Breadboard to your computer. Now, as always, just a quick note, even though this is a live stream, you can pause at any time to go over something we've said or to take a closer look at one of the steps. Additionally, you can contact us with your questions at any time through the EduKits live stream email address, which can be found in the sidebar of this video or by emailing us at ls@edukits.co. So that's ls@edukits.co. We will get to some of your questions for the Q&A later on after we have been doing this session. So, without further ado, let's get to assembling the parts of our very first invention for today, which is the burglar alarm. Let's switch back to the iPad cam. Now, for this invention, we will not be needing the light sensor or the resistor. So I will move these away to the side. I will also move away some of the parts until we need them. I will start off with the breadboard. I want you to take a close look at this component because we haven't used it before in our workshop. So I'll bring it nice and close to the camera so you can see it. And you'll notice that we have numbers and letters going along the sides and the top and bottom. So if you take a close look, you can see that we have number 1, 2, 3, 4, 5, 6, 7, 8, and so on, all the way to 17 right there on the breadboard. And you'll also notice that we have letters up the top, A, B, C, all the way to J. The way this works is you put wires in them like this. So you can put a wire and you can connect it somewhere else or to the Breadboard. But the reason the Breadboard is special is every single hole in every row is connected. So all of the, this one, this one, this one, this one, and this one are all connected because they're in row 1. However, this divider down the middle separates these two columns. So everything over here is connected, but not to this. Then row 2 is connected to itself, and row 3 is. So if I plug in a wire over here, and I plug in, let's just pretend this is a different wire, I plug in another one over here, these two wires are actually connected through the breadboard. However, if I then move it to the row above, these two wires are no longer connected because they're not in the same row. And if I move it over here onto the other side of the divider, these wires are also not connected because they are separated by the divider. So that's how the breadboard works. And it's time to use this to connect the ultrasonic sensor to our brainboard. So I'll disconnect this and I'll bring over the ultrasonic sensor. You will notice that it has two things that kind of look like speakers. The way these work is one of these emits a sound and the other receives it. So the sending one will send out an ultrasonic sound signal, which is essentially at a frequency we can't hear. Dolphins make that kind of sound. It then bounces off the distance, the object. Say it's my hand. The sound will bounce, send out, bounce off, come back, and it will determine the distance based on the time it takes to come back using the speed of sound and some fancy schmancy maths. So it's time to connect this to the breadboard. All you need to do is line up its pins to the holes on the breadboard, center it up, you can see that's in the center of the board, and slide it in. Wonderful, that's connected perfectly. Now it's time to connect the wires. So you need to grab 4 colored wires. It doesn't matter what color these are, just remember kind of which color I'm using and which color you're using. Okay, now you will also need the brainboard. We're going to connect the breadboard and the brainboard together in this step. Take one wire, we're going to do one at a time so you don't get lost. And you'll see that we have labels on the front, but don't worry because we'll be going from the top to the bottom. So if you see this top leg here, I want to plug the first wire into the same row. You can plug it anywhere in this row. I'm going to go here. I'm going to plug that in, and this one is VCC, which means we need to connect it to power, so 5 volts. And that is along here on this side of the brainboard. The next one down, just get another wire and pop it directly below your last one. So in the row below. You can see that this one is trig. So this is the leg we use to trigger the ultrasonic signal. I will connect this to number 9 on the brainboard, and that is over this side here. Next, we have the echo pin, which is triggered by the ultrasonic sensor when we receive the ultrasonic signal back. I'm connecting this to pin number 10 on the brainboard. There we go. And lastly, we have ground, GND, and this is on the lowest leg. So we're actually skipping a row and going down. We don't need the other leg there to be connected. So connect this over in ground, GND, which is over here. That's all connected. And the last thing to do is to connect our buzzer to the brainboard. We are not going to be doing this in the way we normally do, so just by sliding it into the pins, because it actually won't fit because of the way we've connected the ultrasonic sensor. However, I've done that to make sure we have a bit of extra practice with the breadboard. So I'm going to connect the long leg over to the very edge, the very corner hole over here. And if you take a close look, you'll see that the short leg is separated by 2 holes. So you need to remember that distance. So I'm going to get another wire and I will connect it to the same row as the positive pin. So that's this top row over the other side. I'm then going to connect it to pin 11 on the brain board. So that's 10, 11, oh, 11's right above 10, right there. Lastly, we need to connect the buzzer to ground. That's GND. And if you remember, we had a 2-hole gap between the two. So that's 1, 2, and that's where we place our ground connector. Then I will put the other end over into GND over here. 12, 13, ground. Done. Now, our entire invention is assembled and is ready to get started. So I will now connect this to my computer using the blue USB cable that came with the brain board. One end needs to go into the brain board and the other into your computer, and you'll know everything's working when you see the power lights turn on. There we go. It looks like this has code from another invention, so I'm just going to clear that now. Wonderful. We're all good to get going. Head to the EduKits website and we'll do a screen capture to show you how to do these next steps. Wonderful. Now you can open CodeKit using the top menu bar on the website and clicking code, or if you are currently on our live stream webpage, you can click the Launch CodeKit button in the bottom right. Once the application has loaded, we will need to just make sure you have a few categories enabled so that we are able to do today's activity. Under the settings menu up here, which is triggered by the cog icon, make sure that you have the checkbox selected next to messaging, timing, and input and output, as well as logic. And click close to refresh any changes. You can enable and disable different block categories to show or hide different kinds of blocks through that settings menu. And it's important because we need our serial monitor communication today. If you remember from last week, we were able to kind of chat with our brainboard, so send messages to and fro, and we're going to be using that today with the ultrasonic sensor. Before we build our burglar alarm, I want to get us to check that the sensor's working and to get a sense of how it kind of operates. So let's set up some serial communications. You'll need to go under messaging and set serial bitrate and set this to 9600. If you remember last time, this was the first piece of code that appeared in our serial communication. Next, we will need to send a message over the serial. So this will send a new line over here and a message will appear in the little window. Then we want this message to be the distance. So essentially all this code is doing is it's going to send us a message of how far away the closest thing to the sensor is. The last thing we need to do before we upload is to add a short delay, and I will change this to 500 milliseconds. So we'll get an update of the distance twice every second. Now it's time to copy this code and upload it to the Arduino application. Here we go, I've pasted it in, so I can click this upload button and send it to the brain board. You'll see over here that we are getting 150, 150, 150. That's the distance between the ultrasonic sensor, which is on my desk, and the wall behind me. If I stick my hand in front of it, you can see that it changes to 10. And this is a value in centimeters. And it's actually quite accurate. My hand is about 10 centimeters away from the sensor. So we know it's working and we have a value and we know it's in centimeters. So now it's time to trigger a buzzing sound, a beeping sound, an alarm, if someone gets too close to the sensor, because then you know someone's tripped it. I will close this and I will come back to CodeKit. If you remember from last time, we can use an if block to trigger code if a condition is met. So for example, if someone trips the ultrasonic sensor and comes too close, And that could mean your mum's walking past with your washing. So you'd want to trigger the alarm for that to stop the intruder. You'll notice that if we try to drag the sensor distance into there, it doesn't really work because the sensor distance is a number, but we want to know if something is true. So you need to go under logic and drag this little comparison block over here. The way this works is you can see that there's a thing on the left and a thing on the right. If those two things are equal to each other, then it will run the code in there. That's what the if means. We want to change this to a less than and drag the sensor distance into the left one. So we can say if the sensor distance is less than blank, we will do the code in here, which we are going to change to be the buzzer going off. We need a maths block to create a number here because we want this to be less than, say, 30 centimeters. I'm just going to make this 30 centimeters, just for now. But you can change this to whatever you like. So that's when we are going to trigger the buzzer sound. I'm going to delete the rest of the blocks here and add a buzzer noise. Now I'm going to go through this buzzer very quickly because you all know how to make noises by now. We're going to turn the buzzer on. We are going to wait a little bit, turn the buzzer off, and then wait a little again. Now, don't forget to change the pin number to number 11, and we can have the delay at 500 milliseconds, for example. Or even better, I'll just make it 250 to make it more annoying. Okay, so this buzzer is going to go off when someone trips it. Trips the sensor. Now I've copied the code, pasted it into the application, and we'll see if it works. Now, I'm going to stick my hand in front of the sensor. There we go, and it's working. However, you'll notice that whenever I move my hand away, the beeping stops. And to keep the alarm going on, I have to stick my hand in front of it for a prolonged period. To fix this issue, we need to put a loop in. So if you go under loops and repeat, drag this repeat 10 times block in, now we have an option to repeat some certain code 10 times. I'm then going to click and drag the rest of this code inside of that, change it to 5. So what this means is that whenever our ultrasonic sensor is tripped, we are going to beep 5 times, which means someone can trip it and it won't immediately stop, but it will keep going. Your intruder will not be getting away with this one now. I'm uploading it, and now when I stick my hand in front of it, my hands aren't there, but it's still making noise. There we go. We'll go again. As you can see, it's working very well and as expected. Now, going back to CodeKit, there are heaps of things you can change to make this invention your own and to make it more annoying. You can change the distance that triggers the alarm. You can change the number of times the alarm beeps before the system resets. And you can change the frequency as well as the delays between the beeps. So that's our burglar alarm invention done for today. It's time to move on to our next one, which is the electronic Cricut. And this was the very first invention created for the amazing Annoyatron, so it is one of my personal favorites. So we will disassemble this invention and build the next one. I will unplug this from my computer and I will move it over here so you can see it. And we'll go through the assembly. First of all, remove all the wires from the brainboard and from the from the breadboard. So I will remove that and just slide the buzzer into the brainboard the way you normally have it. So the long leg goes into pin number 11 and the short goes into GND like that. There you go. Done. Buzzer is all good. The next thing you'll need is the resistor and light sensor. So the resistor goes into A0 and GND. Here we go. Oh, I'll move that in there so you can see it. that seems pretty good there. It does look a bit wonky, but that's okay. And the next one, this light sensor, goes into A0 and 5 volts. So I've connected that all properly, and it's time to connect that to the computer. Now, this is the same wiring as our Wakey Wakey project we did. So you will have already done this if you've been following along with our workshops. I'll connect this to the computer and clear the code because it has the burglar alarm from last time, and it will keep going because there's no sensor. So obviously there's no delay between sending and receiving. Here we go. I'm going to close that last project, and we can delete all the code here by clicking this trash icon, but you may want to save it if you want to come back to your code from the last one. Click OK, and it's time to create the Cricut sound. Now, the first thing we need to do is add some buzzers, some buzzer blocks. We need to have a buzzer on and a buzzer off because that's the basic way these sounds work. However, we will work the delays in such a way, and the frequencies too, that we have a sound that sounds like a cricket. So instead of turning the buzzer off at this point, I'm going to just change the frequency. So we're going to change the first one to 5,000 Hertz, which is quite a bit higher than we normally use. And I'm going to change the next one to 10,000 Hertz. Cool. Don't forget to change the pins to 11, and we're going to use a very short delay. So 30 milliseconds and 10 milliseconds respectively. Copy that code and head back over to Arduino. Paste it in and then upload. If you're working on a new document, you will need to save. And here we go. You can hear that that is making an annoying sound. I'm just going to disconnect that for the moment. It kind of sounds like a cricket, but it's important to remember that crickets kind of go. I'm clearly not a cricket. My cricket sounds sound horrible, but that's why I've got the Annoyatron. So there's kind of a short burst, and then the sound comes off for a moment. So to do that, we can do another loop again, because remember, all of this code from once it finishes and gets to the bottom, it just goes back to the top. We need to repeat this code and then have a break before we loop back to the start again. So grab a loop, set it to 5 times. 5 seems to be the magic number today. And stick a delay underneath. Now, it's important to remember that this code actually won't do anything too different because we haven't turned the buzzer off at any point. We've just changed the frequency. So you need to add a stop sound block underneath and change it to pin number 11. And finally, change this delay to 300 milliseconds. Let's copy the code and upload it, and you will hear a difference. Just don't forget to plug in your board again, because that's an important step. Set the upload button. There we go. We have the cricket sound. And now it's time to add the very last step, which is to make it light sensitive. I'll unplug it again. So the reason this cricket is so special is you hide it in a dark room and it will make a cricket noise because, you know, crickets, they love the dark. However, you'll also know with crickets, when you come over close to them or, you know, you bring out the lights, they stop chirping because they realize you're coming around. And this invention takes the magic of that and really brings that into play. The way it works is we're going to be adding an if statement. So we are only going to be running this code if it is dark. What that means is when you place it in the dark room, someone will come along and turn on the lights to find it because it's so annoying, except that very act of turning on the lights will stop the sound and they won't be able to find it because you've hidden it well and there's no longer a sound for them to kind of track with their ears. Of course, they will then turn the light back off to go away and the noise will start again. They haven't solved the problem. They'll turn the light back on, the sound will stop again, they'll turn it off, the sound will start again, and they'll get really frustrated because they don't know where it is and it's really annoying. The one thing you will need for this invention to do that, on top of that, is this battery clip. Of course, you can plug the Annoyatron into your phone charger if it has a USB port, But you can also use this 9-volt battery clip, which plugs into the barrel jack of your Breadboard. You plug this end in here, and you can grab a 9-volt battery, which I have here, connect it up to the clips, and you'll see that our invention is still working. There we go. I'll disconnect that for now and connect it back to the computer so we can add that light functionality. What you want to do is, in Cricut, grab an if block from the logic section, wrap it around all of that code. Now, I'll show you a little trick here. We can use the comparison block rather than our light sensor block because we know how to use that comparison one now. We can grab the light sensor value and set it to less than 100. Here we go, and that will test whether or not it is dark. So if it's less than 100, that means it's quite dark and we are safe to essentially make our noise. So when I upload this code, it shouldn't make any noise because it's not dark. And it's uploaded. So you can see that we have lots of light in this room, and for that reason, the buzzer isn't going off. However, I'm going to cover the light sensor, and that means it's dark, and you can see that the Cricut is going off again. There we go. So that is the electronic Cricut, the very first invention that was created for the amazing Annoyatron. Now, we're going to take a short break and I will be back with to answer some of your questions. We're just going to be checking the emails that have come through. We'll see you soon. Hello, welcome back. And it's time to head over to our questions to answer some of the emails you have sent into us during today's live stream. Of course, if you are watching this later, which I know many of you will be, because it is on an unusual day, we will be able to answer your questions just over email. So send us an email at ls@edukits.co, and even though many of you will be watching this after this has been recorded, we will still be able to answer your questions there. So over to the questions. Ben has asked, can I connect my Breadboard to both the computer and the 9-volt battery? So that's a good question. Whenever you connect the power source here and the USB, the USB will take preference. So essentially it won't harm your board and the power will come from the USB cable. That's done so that you can upload to the computer and the board will still work as you'd expect it to. So it won't do anything bad. Emma has asked, the 100 value in the Cricut isn't working. The Cricut is still buzzing, even though it is light. Okay, so this value might be slightly different for your light sensor, depending on, it just changes slightly with each light sensor. So if this 100 value isn't working, you can bring it down a little bit. So if it's still buzzing, you just reduce this number until it stops, and that will fix the problem for you. And the final question we'll be answering today is from Lachlan. He says, I can't see the messages option within CodeKit. How do I get this? So we did go over this earlier in the workshop at the start. You might not remember. I will go through it again because it is an important step, and this one is a little bit tricky. So go into the settings section, and then you will see under block loader all these different categories. Make sure that you click the check the messaging checkbox. If the checkbox doesn't work, just click the text and that will definitely do it. Click close and save your preferences. Well, that brings us to a close for today's live stream. I hope you have been enjoying this series. It's been a pleasure to walk you through these amazing Annoyatron projects. I hope you have so much fun with the Annoyatron as you continue to use it. There are heaps of projects on the website, and we are still adding more projects, more things for you to build. Well, I would say see you in the next one, but we don't have another one. There are heaps of videos on our EduKits YouTube to walk you through different things you can do with the Annoyatron. And let me know if you build anything cool with it. Send me an email at ls@edukits.co. Thank you for joining us on this journey.